Hi everybody, my name is Jimmy Carroll. I'm the Vice President of Operations at Tech B2B Marketing, and welcome to this special episode of the Manufacturing Matters podcast, where we discuss the trends and technologies shaping the manufacturing industry today. I've got a great panel of folks today to discuss machine vision trends. I'll put on the line here Steve Kinney from Smart Vision Lights, Jason Covar from the Imaging Source, and Jeff Adolf from 3M. Guys, thank you so much for taking the time. It's a busy day here at the E3 Business Forum, but I appreciate it.
Thank you.
Thank you.
Awesome. Well, the pleasure is mine. I'd like to start, we'll jump into questions in a minute, but I'll start by asking you guys each to just kind of introduce yourselves and what you do at your company.
Okay, I'm Steve Kinney, Director of Training and Technical Solutions for Smart Vision Lights. We're a leading supplier of LED lighting for machine vision, and as my title implies, I do inside training, outside customer training, and other videos and promotional material for us, and advanced technical solutions when we have custom designs or other advanced interfaces or applications.
Jason Covar, General Manager for the Imaging Source, camera manufacturer, machine vision cameras. Oversee the U.S. operations, which also includes more systems and software as the market has evolved, which I think we'll talk more about today.
Jeffrey Adolf, I work at 3M, so I'm the vision technology lead for our internal manufacturing technology team. So we service our own internal customers only. We work with manufacturing teams around the globe to help solve their vision problems, improve processes, improve quality.
I'm looking forward to diving in here a little bit, but again, just a kind of fun opening question is, what are you guys most excited about in machine vision today? And maybe Jeff, if you want to start on that end.
Yeah, I think it's going to be probably the expected answer is kind of the intersection between AI and vision seems to me to not just enable new opportunities, things that we obviously couldn't have done 5-10 years ago, but I also think there's a huge opportunity to drive vision into places that it maybe wasn't before, and I know we'll talk probably about some embedded solutions too that are doing some of the similar things on another end of the spectrum, but I really like the idea of AI being able to enable more rapidly deployable solutions, maybe solutions that are maintained at a lower level. And then, of course, your very high-end solutions that can only be done with that. So, that's my answer.
Yeah, I think it's an exciting time in the space. I think there's a few changes in the market. There's a lot of talk about AI, but hardware-wise, I think there's a transformation. To what Jeff said, there's other opportunities with markets that weren't traditionally our customer base a few years ago. So the customer base is opening up, but I think it's the responsibility of the companies to match that, right? Meet the customer where they're at. So that's an exciting time for us to be able to put all that together.
And I would say things along similar lines. We could talk about linear axes of various technologies, but as it all comes together, I think two things are happening. One, the capabilities and the ability to solve problems for a wider variety of customers, combined with the market awareness, and now is the time for automation, and the market is coming to us. I think all of us would agree we've had technical capabilities beyond what the market's demanded for quite a while, and the awareness and maybe the buzz around AI actually makes customers, we get more inquiries, we're doing more and more things, and those areas include wider areas than ever before: food, agricultural applications, all kinds of places where we can apply vision and make a difference in their applications and end results.
In the larger space, the industrial automation space, there have been some notable developments as of late, whether they're acquisitions, mergers, acquisitions, or large investments in production and manufacturing facilities in the U.S. What to you, and obviously Jeff, AI, this is among them, and feel free to continue to bring it up as we tend to do on the podcast, but there's a reason for it, right?
Yeah.
It's very exciting. But back to the question is what are some of the most notable developments to you in automation today?
Yeah, so I'll focus on vision, obviously, because I think as a broader category, there are some really cool things that are happening in automation from the robotic side. But I think from vision, I'm excited about, a little bit to your point, Jason, I'm really excited about the opportunity to use vision as a sensor in so many more applications to deliver data that's relevant and then usable through AI. So it's not just hey, you put AI together with the image processing backbone of your vision system, and you get something that's new, right? That's cool, and that's what we've been doing, right? But I also think there's a lot of opportunity now. Hey, I can generate unique data from vision sensors that we just didn't exist before. And we can take that data and incorporate it with our process data, incorporate it with our SAP data, incorporate it with our safety data, right? And those kinds of things to me are opening up avenues that as technology people and as automation people are incredibly exciting.
Yeah, I think sometimes we overlook, we look at what's in front of us, and AI is talked about a lot, but sometimes if we zoom out a little bit and we look at the fundamentals that are right in front of us, there's a lot there. And I think vision falls into that group. We work with groups that have supply chain optimization through AI, where it really is an asset, but now they're looking to build digital and vision groups to do the verification, right? So supply chain is optimized all the way to a certain point, but that visual representation is key. And so I think we're seeing that as a big part. And for the adoption, when you talk about adoption, I think like Steve's role is critical for our companies, right? The pace for adoption of technology comes to the training and educating, and I would say that Steve's in the perfect position to do that, and in a lot of companies that does inhibit the growth of that. So I think that's, to Jeff's point, I think vision is an area of growth as well.
Yeah, and I think it's an exciting time to be in vision. My history is in cameras, and I'm working in lighting now, but I've been in this industry doing vision since 1998. And I think, again, if we start talking about technologies, the sensors, the resolution of the sensors, the multi-spectral aspects, the spectral ranges of some of these sensors, other advancements of multispectral, non-visible imaging in general, and the widespread use of that now, or the increasing spread use of that, whereas it used to be a little esoteric. I think all these things are really interesting. I think there's technology behind each one of these that are making them each enabled more and more on their independent axis there, and the things we can do with vision, it just helps widen the breadth of solutions we have. And thanks, Jason, for that tag there about the education. I think it is key. I think through the A3 we offer CVP and other courses. Through private companies like SVL, we do trainings twice a year on site. You can sign up for free. And it's important to make sure you understand a little bit about all this too, so that as you're coming to us with a problem, you understand in some context around there about what we're going to solve for you, and maybe understand some things we're going to talk about.
Yeah. And I would say, I think AI in general, right, you could take the fireball approach of putting it everywhere in your company. I do think the hardware companies are the gateway to a lot of this, right? To deploy it in a way that works and scales, it does rely on the hardware. So I think from the hardware company sides, I think you'll see benefit from this.
Yeah, and it's important to kind of give vision its flowers, right? Like automation, in the automation space, a lot of these trade shows like robotics and of course AI, and especially humanoids, kind of steal some of the thunder, but machine vision is a critically important enabling technology, and you look at the ways that all these technologies work together to solve new challenges for customers, and without vision, you can still solve certain things, like robots can do pre-programmed paths. Think about AGVs versus AMRs, like with the incorporation of sensors into the AMR, like it's a lot more flexible than an AGV is. But there's a lot of other examples of that too. Like, what are some examples of how vision is kind of opening new doors in automation in general?
Yeah, it's a good question, because I think there are so many areas. One that I mentioned and I'll bring up again is, I think the ability to get not just data but information from things on a process line is enabled by cheap embedded vision. So if you have, for example, just a simple example, right? You have a new piece of capital equipment for making a widget, right, coming into your floor. It's now almost de facto that's coming with 3 or 4 cameras that are looking at the process, saving to an NVR device, and maybe there's some intelligent video saving for when there's an upset or when there's something. This is such a simple thing, and it's not something that we couldn't have done 20 years ago. It's just something that now is de facto, right? Vision is becoming kind of hey, I need information. How do I get it? I'm going to put a camera on there. I also think I'm personally really excited in the area of more of the broader area of factory management as opposed to maybe specifically automation. I'm super excited for what AI-enabled vision can do. Simple example would be human safety, right? We're not quite in the automation world, but we're still on a factory floor. But you can imagine when we have at 3M implemented solutions that help maybe real-time alarming for no-go zones, right? Or shut down lines if you're in an unsafe area. Or even simpler, we have a lot of systems that are simply understanding what are the safety risks in certain areas of the plant, right? What are the ergonomic risks that we're continually seeing with our installed CCTV network that, again, most plants have. So this is using existing camera systems and leveraging kind of the new AI technology to make them more interesting, but also just the proliferation of little cameras are everywhere, and I think we're going to continue to see that.
When you say that, you're talking about like agentic AI?
So it can be agentic AI for sure. I think that big companies move slowly, right? So 3M is moving slowly, but even if you have, let's say, dashboarding of true information, not just data, but hey, these are the insights that I have gleaned from these 17 cameras that I have looking at this process, right? That's a dashboard where a process engineer can look at that and understand what's going on in his line, or a safety manager can understand about the risks that are happening in his plant. We're not quite, at least at 3M, to the agentic side where you can take an automated action, but just getting that information, not just data, in front of an engineer or a technician makes the time to problem solving so much faster.
I think there's an important, I think that's important, and as I listen to that, we talk about vision going in more places than ever, and I think I agree with all of this. I've worked personally on applications where we've done people counting in stores and stuff, right? To know where they go, study the data, and these are more accepted now. But I think the point in there is there's a whole range of these things now. We're used to having these simpler cameras everywhere, and then you can start gleaning data like this and tying it in, all the way to the high end. We have 50 and 100 megapixel cameras, and we're able to do stuff down at micron level and the inspection world and stuff, and everything in between. And I think it's a tremendous time for vision in general, and just the explosion in these areas. And I think AI just enables the possibility and furthers that explosion.
Yeah, and if I could just quickly add on to that, I think the onus is on us, right, as us, right, I guess, here, to not allow us to be stuck in one of those domains, right? I think it's too easy to say machine vision means this. It means a 50 megapixel camera looking at a semiconductor wafer, right? That's not it, right? There's a huge broad range now, and I'm super happy about that.
I think that's a really good point, though. When I was product manager for JI, we started hitting that point, and even Polnick's a little before JI bought them, but we started hitting those points in the early 2000s where you started seeing things. You started seeing the simple drones and the smaller cameras and what I called cell phone cameras everywhere. And at first, as a camera guy selling, we're selling Kodak imagers on bigger pixels and dynamic range over Sony and other things. We tend to focus on that. At first, I kind of dismiss these as, well, if it's that far down the market, it's not ours. But the truth is, we have to own all that as vision, and that if you're doing that, you're leaving stuff on the table. And I've learned to embrace all of this too, but I think it's important for the market out there to look and make those adjustments as well.
And I think you hear the computer vision, right? You hear this terminology, and I think we talked about this last year, and the definition of that, but I think it feeds into what they're saying. When you think about the AI, the output is dependent on the input, and I think Jeff brings some good points as well as Steve. So vision can be a critical input to that, right? So you watch the processes with cameras, then you feed the AI to have a better output. So I think it's complementary in that way, but others may see it in the opposite. The AI will do all the work, but the input is very, very important for successful output, right? And vision, as you said, if you put something on the floor, you put it into the process, and you actually watch it, that's very, very valuable for these systems to work. So.
Yeah, I mean, if you think of AI as programming with data, if that data is poor, then what do you have?
I think the other side to that, and to build on that a little, I'm also vice chair of the imaging TSB, the vision and imaging TSB for the A3. And within the imaging TSB, as Jeff and Jason are on here too, as we talk about these things on the TSBs, on the technology strategy boards, and help the A3 develop their vision for this, we've asked the question, what does vision look like in 10 years from now? Because we're used to, it used to be a CCD camera, now it's kind of CMOS, and now it's kind of visual, but we'll go outside into the non-visible. But as a board, we're looking at that, and vision is going to go far beyond that. We had someone exhibiting CT scanning, for example, at the last Automate, which I found really interesting, alternative X-ray, and you have the whole terahertz scanners in the airports, which haven't really permeated themselves down to the automation world, but I think it's coming, or that there's potential in these areas, and vision, at the end of the day, is the input to all this, but vision may not be traditional human-based vision like we think in just a camera.
That's a great point.
Steve, we get the chance to talk about this a lot, but like you think about hyperspectral imaging kind of migrating beyond the lab, or 3D imaging kind of coming of age, or even more recently like developments in SWIR sensors that have kind of made SWIR sensing much more approachable for factory floor, beyond just R&D, whatever. What are some other technologies, whether it's from the vendor community or whatever, that are kind of opening new doors for different ways to solve applications? And specifically, one thing that comes to mind is like processing. Right, there's been a lot of really interesting developments in like FPGAs and SoCs and GPUs are no longer this big, Jetsons and all these other. So, and Jason, I know we're going to talk embedded vision too, but let me stop there.
Well, I think we can talk about, and I think the magic in that is it's easier than ever. The processors are more powerful, they're smaller, and in some cases you don't need much of a processor. I've seen people deploy Raspberry Pis and Arduinos, for example. Raspberry Pi in particular can grab an image and stuff if it's not high bandwidth. As you exceed that, then you can get into the embedded processors, and then as you go to AI, we of course then start talking the new Jetsons and all the things around that. I think the important thing for the audience to understand is there's more processing power in incremental steps available at price steps that are proportional in that, and that you don't overdo these applications. It's important to look at this, get a definition about what I'm trying to do, deploy a lean amount of resources towards it. But I often ask people, there's nothing wrong with the smart cameras and building that in, but in the smart camera, you get a certain selection of images and stuff there's a certain framework that's baked into that. And I often ask, what's the difference between a smart camera and having a cigarette size processor sitting under the table, and then I can use any camera, including much smaller cameras where there's a weight or a size issue, as a tether to that, and it's basically a remote head, a smart camera at that point. So I think a lot of people get into this and, I need this, or, Cogniz told me this smart camera, which is absolutely fine answer, but make sure you're weighing that out against the benefits of that architecture versus maybe making a discrete system and where we make it all work together today like it's a unit.
Yeah, absolutely. I think the smart device, single piece of hardware, I think there is some decoupling from that in the market for sure. When you think about scalability, cost always comes into it. So there's one attribute of embedded that helps. I think when you look at the software side, data scientists, others working with all the data, love the GPU or love the capability. I think the market, there's a disconnect between what I want and what I believe we need and the deployment. And again, I want to go back to Steve and training and educating. I think as a group and a community, we really have to educate the customer side for this to scale when we talk about embedded vision. From a manufacturer perspective, it's also a system level sale. It's not a component. whereas most of the machine vision world is used to selling at a component level, putting things together. So this is a shift as well. And then the other thing I would like to say is synthetic data, when you talk about new systems and how it's working. I think this is a big improvement and does help a lot. So I think this is an area you'll see more and more. You hear it more, but I think it is a big step forward. It helps a lot of things that may have been successful in the past with having this data and being able to work with it in real time. So that's what I see. Embedded with synthetic data is more and more commonly required and asked for today, I should say.
I'm glad you brought up synthetic data. That was the first thing that came to mind when you said that. And I think there's some maybe Horizon 2, 3 technologies that are not quite there, but yeah, synthetic data is something that you see extremely commonly, and I think it can certainly be overdone as well. I think there's a lot of applications where if you were simply to deploy a camera and get real data, it's just simply better than synthetic data. But I think having that alternative maybe for huge SKU mixes and things like that, we see that happening at 3M. The other, maybe more of a question for you guys than a comment, right? Because I've been pondering this same question about where the processing happens in a chain, right? So typically, like, you can have your smart cameras, right? Very, very simple. It processes on the camera. You have a huge amount of power to do that, and then you get a result out of your camera. You can do, I don't know, 10 years ago, everybody was saying, well, everything forever and ever will be in the cloud. It will always be processed in the cloud forever. And that hasn't panned out, right? But there's a place for cloud processing. I've been seeing as again this trend that I've mentioned, where you start getting more of sensor style cameras, right? Things to just monitor, where you may have had a prop sensor before you have a camera now, right? I've been pondering, do you guys see a shift now where individual cameras will be making, you have 30 cameras in a small area all making individual small decisions and then feeding that up? Or do you see it percolating all of that data to a larger processor, maybe to the cloud, maybe to on edge? Yeah. I'd be interested to hear your take there.
Yeah, absolutely. And I think you're right. We've seen an evolution. Everything was cloud, it was on-prem. There's, it's kind of driven by AWS.
You missed the fog. That was the between. Between is the fog. Yeah.
What I hear, and in part, I mean, you know it as well, probably as any of us, with a company like 3M, if you want to scale something, the IT layer does come into it. For sure. This is a big piece of slowing down, stopping completely, taking things off course. But I think on-prem for the data, but also for quick decision making.
Yeah.
You would inference on this device and make a quick decision in a binary way, right? We don't need to send it up to the cloud. We're not doing all this calculation where we really can train, and we can inference on this small device, literally closest to the problem, and make that binary decision.
Yeah.
And this seems to be the trend. I think the cloud piece, from what I hear in the market, has moved on. And I think also companies, security, where your data is sitting, is also another one that you hear. They say, well, we're not so comfortable, in a POC or something where you're pushing all the data, but enterprise level, you don't want all of this data going up to the cloud. And so I think the on-prem is certainly the way. But to your point, if you are to inference and make a binary decision, where there's plenty of this opportunity within the factory, I think that's part of the attribute as well as embedded. You get closer and you're able to do that with the compute.
So I agree completely, and that was a leading question, but I also, let me play devil's advocate real quick, and I want to hear your idea too. With AI now being able to glean more information than it ever has before from data, there seems something almost heretical about getting rid of all of this beautiful, rich data before it hits a real processing unit. Like, is there, maybe it's just application dependent, maybe it's whatever. I couldn't hear you any more about IT and cybersecurity at a company like 3M. It's like it's a problem, right? But I always kind of have this back and forth. Is like, I'm getting rid of so much data, and look how many more things there are to produce to use this data with. But at the same time, I don't need that data. I just want an answer, and I want it to be done here. It's self-contained.
I think there's an interesting parallel to that. I think that's a futuristic question, and a little bit's to be seen. Some of it by application, some of it will be by which architecture wins. And what I mean by that, if you think about drones, there's a whole thing about, well, I have a drone and I can do it, and you have farming and hyperspectral drones and stuff now. But there's also a whole contingent of drones where I have a hive mind, right? And we all kind of share that, and they can move and act as one thinking. But I believe that's trickling down to our level too. So when you ask that kind of question that way, you made me think about that a little. And depending on the application and other things, you may very well have smart cameras that have a little bit of smarts, but kind of a hive mind communication, and they all see a little something, flip a little switch, but make an obvious.
We're back to IoT. We're back to IoT. It's like this is the big circle of life, isn't it?
I think the difference is, I do agree, and a little bit of Stranger Things as I talk about the hive mind too, for those fans. But I think the point in that is, where's the data going though? Because in the hive mind, there's a little bit of IT and IoT going on there, but it's all just right here before there's a decision made, and then it goes upstream. And in a lot of cases, that's important because you can overflow everything going upstream if you're not doing something.
And I think you're right. So I mean, the asset is the data and the image, and as a vision person, we would always see that. You would implement a vision process, and you say, oh, I could do this, that. 4 more steps out of that data. I think what you see is you see the decision making, but maybe the data doesn't lose, it's just not in real time.
Yeah, sure.
So it's kind of more of a canary update kind of style where it's not there, but overnight. When you're downshift, you still keep the data, but you're right. Yeah, I think they're doing the targeted decision making, but that is an asset and it should be still.
All right, I'm trademarking my fog. This is between the cloud and the edge is the fog.
There
this
we
is
go.
where we're going.
When it comes to those applications, though, that we talked a little bit about embedded vision. I guess this is kind of a question for everybody, but when you need, like, I want to say real time, but near real millisecond latency, right, for applications, like what are some of those applications that you're seeing out there these days that require those, and what are some of the solutions whether it's FPGAs or SoCs, GPUs, like what are some of those systems look like?
Yes, I mean, if you just step back and look at the architecture of embedded, like this was one of the attributes that made it become, more popular, the latency, right? So when you started in vehicles and you had these ADAS systems, you need really, really low latency. So the idea was grab the image, put it back, and process it on the board. It's kind of spun out of that. I think you mentioned drones, for example, right? Something that is dependent on the flight of something has to have a low latency. When you think about that, that's one that comes, at the top of mind. Because if you're controlling some kind of vehicle or aircraft and you have to make a decision on pitch, this has to be almost a real time.
Especially in defense, right?
In defense, right? So a drone, if you're making a decision on where that's going. So that would be one that's also popular. There's a lot of conversation around defense today, here and in Europe, and that would be one that comes to my mind.
I'd echo that too. I have a significant amount of experience with cameras in defense, and some of this is in the architecture again of these solutions. This is why you pick certain interfaces or architectures as well. I can remember in the high end, 15 years ago, I had a group putting cameras on the axles of Humvees and some of these other things and using them like accelerometers, because these guys are often piloted by a guy in the back, or even if there's a driver, there's a guy in back that's watching all around the vehicle and making strategic choices about what he's seeing 360 around the vehicle. The number one thing is when the vehicle moves, that guy gets motion sickness. So they actually put cameras on the axles and watch the vibration of that axle to stabilize the image and stop the motion picture. But the point in that is CameraLink is the only real-time spec that's out there, and it's still out there even though it's a long time. I see Jeff making a face.
I have all of my installed infrastructure as CameraLink.
Yeah,
so I'm not hating.
I think it's funny, people don't talk about CameraLink and you got to know, I love USB Vision because I'm a guy that used to have to drag around a frame grabber, a PC, and just to show the camera. They have their place, and there's nothing wrong with the USB and Ethernet. They have high bandwidth, and we get the job done. But by the nature of the packets and the nature of their communication, it takes time to put those together. When they were doing acceleration on the axles, they're reading, camera link is real time. Here's my clock cycle, here's my 80 bits depending on the configuration, and absolutely it's just a modified parallel LVDS. But my point in that is, in the time you're putting a packet together for Ethernet, they'd already read the first 10 lines of the image and were computing the motion vector long before they even got the whole image in there. So I think a lot of this depends on the application, and again, we have high-end capabilities, but that kind of capability is not for everything either, and there's vision everywhere with low-end capabilities. And you need to think about the architecture and not overdo the solutions or underdo the solutions.
Yeah, I think my answer is maybe a bit anticlimactic. Honestly, the vast majority of the applications that I see are not latency constrained, they're throughput constrained. That's so industry dependent, right? I understand 3M is not maybe an automaker or defense, obviously, right? But for us, it makes a lot more sense to have that balance of, hey, we know what throughput we need, right? We have film that's being made, high-speed film that's being made, right? And the question then is what's the architecture that makes the most sense to match the throughput? And so some of that is, hey, now we can do parallel GPUs in a single server, and now our costs are way down. We don't have to have a bunch of servers. Maybe that's we simply just have an embedded GPU, little NPU, whatever it's called, right, on board, and hey, it processes it quicker. So for me, I don't see a ton of very, very high, very low latency applications, but throughput is obviously something we talk about every day.
And it's interesting you say that, because throughput and latency are two different things.
Completely different things.
The application may need one or the other or both, and there's certainly a relationship with latency and throughput, but they go. And I think it depends on where you're experienced, though, too, because we talk about food and other things, and I often tell the story about sorting rice or beans. Nowadays, that is done on what we call a waterfall. They spread them out on a vibratory conveyor, get them one layer deep, run them off a waterfall. And if there's a rock or piece of foreign matter, as it's falling, it goes by the camera, they detect and often in the non-visible range, this is a rock or at least some kind of matter that's not the product, and they actually do what they call puffing out of there and puff it, and when it goes this way, it hits a divider, it falls in a reject bin. Those things are incredibly real time, and you have to make these decisions with very low latency. And there's many others, in inspection and other things. We have to take action on things that are going by 20 a second sometimes, right? So there are applications that need it.
100%.
And there's other ones that don't, and even though they maybe, the films and stuff are a good example, it's a process, you know what's running out, here's the throughput counts, but not necessarily latency, because you've got 20 feet to make a decision, right?
I'm actually, I'm glad you brought up vision standards, because we're kind of on the cusp of Gigi 3.0. It's coming. Well, it was coming a couple months ago, right? And then it's coming a couple months, and it's coming soon, though.
April.
Okay. But what about what do we have to What do we have to be excited about there, right? There's Rocky V2, and then there's Gigi Vision approaches with GPU Direct, bypassing the CPU for more real-time latency. Like, what are you guys excited about there?
Yeah. So Jeff and I are on the Vision Standards Committee. As you mentioned, Gigi 3 is there. I think the responsibility of our association, and one area we're in discussion to lead, with A3, is something around the MIPI and the embedded space, right? So there's some companies out there that are looking to do this, on a hardware level. But I think as an association, the responsibilities are, part of that, the standardization, and A3s benefit a lot from these standards. So, I think we're trying to put something there, right? It's more of a fragmented process now with all the different components in embedded, but that's an area I think we're going to look to the future and try to lead as an association.
Yeah, I think a couple things, to be excited about, right, from an end user, just bandwidth is going to be the thing that is going to be the most impactful by far. I think something that maybe is a little bit under the radar, but should be recognized, just with all the European cybersecurity work going on, that impacts these standards, right? That's not just a hardware thing. That ripples through these standards. So I think there's a lot of forward-looking work being done to try to get ahead of that too, so that we aren't scrambling when that comes about. I also think it's interesting. Small optical interfaces, I think, also is another thing that we aren't there yet. But I'm personally like, we talked about Camera Link. Camera Link is about as old as I am. It's an ancient system.
1999 when we did the first draft. I mean,
so not quite, but
20 years, but
yeah, it's been and especially with a lot of the data center push. I think that we can learn a ton from all of the data center work that's being done with these optical interfaces and bring that to the machine vision world and introduce a standard that has, that's kind of the Goldilocks, right? It has the high bandwidth, it has the long length, it has no data loss, right? There's a lot of, I think, opportunities looking in the future, but I also think it's maybe getting harder these days. There's a lot of different organizations around the world. They're trying to work together, but everyone has their own interests. I think there's a lot of challenges there too.
I think you brought up an interesting point though in that too, and that's the whole GPU thing, the NVIDIAs and the various forms of that. And I recognized a long time ago, at first I'm like, wow, the GPU is great, and it is, but in a lot of the cases, the actual pipeline into the GPU is the limit because it has to cross the CPU, go up to the GPU. So now some of these GPU direct standards, I think, will change things a little because if we can get the image directly in, they're almost like the old DMA direct transfers to get it into the CPU. You're going to start seeing that, and I wouldn't be the one to forecast what's going to come out of that, but I think almost certainly it's important and that there needs to be some standardization there, but it has to be the next generation as well.
We're gonna get hit with a flood of people here shortly, but before we close out, is there anything that you guys are, let's say, I know it's hard to use a crystal ball, but do you have any strong predictions for the next couple of years, things you expect to see in machine vision, or hope?
Massive adoption. both expect
buy
and
more
hope.
lights, right?
I think we did say, I didn't pitch lights in this one, but I think it's important. I realized a lot when I saw on cameras, I'm like always, the camera's last thing these guys think about. They do the whole system. No, I'm going to have vision, and they go, well, what camera do I put down? But I've learned once I got on lighting, it's the lighting, and the light determines what even comes off the camera. And I think all of this though, just more adoption. All of these things are coming out. I think it's an exciting time to be in the vision space, and it is more and more important.
Yeah, I think I'm optimistic for collaboration, right? I think when we're here like the business forum, you talk to many leaders, and everyone has the same stories and same experiences, and you all shake your head and nod and say, yeah, I've done that. And I think one of the ways to break that is collaboration, right? I think all of our goal is to hit scale, not only from an output perspective, but to make impact, right? Putting it into factories and putting it into companies. So I'm optimistic there's going to be more collaboration, working towards the same mission, and I think the end result of that will be, some successful technology, exciting technology. So that's what I'm looking forward to.
Yeah, I think for me, maybe selfishly, I'm most excited about the creativity that's about to be unlocked. I think the application spaces that we are able now to reach are broader than they've ever been by a large margin. So what's limiting us in a lot of is the creativity to think about where vision can be used in applications that it's not being used in, right? Yeah. I think a lot of people are excited about incremental steps, things that have gotten faster processing times, right? And those are really important things. They allow us to do new things. But what I'm most excited about is just, what's new? What is totally undone right now that we can do with this combination of new sensors, with new processing, with new algorithms.
I think that's a great point, though. We've talked about the next generation engineers behind us and stuff in the forum this week. And I've told people before, I grew up in a generation before Apple IIc's. I remember the first Apple IIs coming out, not being rich enough to do that, and going through that whole thing and learning and still growing up in this technology. And now these kids start with Arduinos, Raspberry Pis, all this at their hands. And as they come on as full-on engineers, all these technologies, everything we talked about is available to them today. And I think the real excitement is just exactly what you said, but fueled by these kids that just take it for granted that this is now the new playing field, and what the heck can they imagine to do with this?
Well, yeah, it's like that anecdote of like there's more processing power in your phone than there was in the computer that sent the first shuttle to the moon, right?
Exactly.
So it's like, some younger people don't really realize like what you have, right? I think it was Alex Shakini earlier, and maybe if it wasn't, I apologize, but somebody, and it's sort of a common sentiment, is like it's never been more exciting to be in vision and automation than it is now, and I think that's going to be true next year and the year after and the year after, and that's what makes this all so interesting and so much fun, and great to be a part of the community. So with that, I'd like to close it out, and but before I do, smartvisionlights.com, imaging source, theimagingsource.com, and 3m.com. If you guys have any questions,
We don't have anything to sell here, but
but you may have questions or comments for Jeff or Jason or Steve, and if you do, I'd be happy to pass them along at manufacturing-matters.com. And with that, thank you guys so much for taking the time. Really appreciate it.
yeah,
Thank
Thank
you.
you.
Awesome.